The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today's Thursday, January 23rd, 2025. Kīlauea erupted, is still erupting, but has had a most recent episode that started and ended in the last 24 hours. So we'll cover that here today, and our usual recap of what's been happening in the volcano over the last week, which is quite a lot as we mark the 1 month milestone since this eruption actually began. How have you been, Dane? Busy week?
Doing pretty good. Volcano keeping us on our toes a little bit, being able to catch these episodes as they begin, and they seem to be pretty short now. This one less than 24 hours. So yeah, we're going to talk about that. And if you have any questions, go ahead and put them in the chat, and we'll see what we can do.
Well, sounds good. All right, so I just realized I forgot to flash up our intro banner here, so there it is for the record. Put it up there, and we'll get ourselves ready for our summary here. Okay, so let's rearrange our screen. And here we go. Aloha, everyone. This is our Hawaiian Volcano Summary for January 23rd, 2023. Today marks 1 month since Kīlauea's latest eruption began at its summit. This is a 6th summit eruption in just over 4 years. Since our last update last week, the eruption ended its 4th episode after 3 days of putting out lava, stopped for 4 days, and then began its 5th episode just yesterday afternoon. It lasted about 14 hours and paused this morning before sunrise after less than 14 hours of activity. This is a video taken of this most recent episode, episode 5, which has been unique in that only the north vent is the one actually erupting lava, whereas the south vent is just degassing, as you see here in the video. There's been another outburst of volcanic gas. You can see all the gas here in the video that has really swept across the area. And that is the primary hazard for people at this point in time, the gases and the Pele's hair, which is falling out from the plume as well. So first to recap, I'll just show you guys a short video loop from the KW camera that shows the onset of this eruption. It reactivates the vents, very briefly floods that southwest part of the crater floor, mostly overnight, and then it wanes by this morning. That same view in a thermal camera looks like this. It goes by fast. You see the first outburst, the vents shut off, and then the lava that's pooled begins to overturn a couple of final times within the footprint that was covered in the last 24 hours here. And that's where the eruption actually occurred. In a map view, it's still in the southwest part of Halemaumau crater, right around in here, with the primary viewpoints being around the volcano house and Kanakakoi overlook here and here, as well as anywhere on this northeast side of Kīlauea Pele, summit caldera. So when these fountains come back, they come back fairly suddenly, and the viewing is pretty good. But as you can tell, they have not lasted forever, especially this last one, quite a bit shorter. If we look at the changes further afield, here's a tilt meter from both a summit in blue and a rift zone in green. And so the summit is tracking the repressurization of the volcano in between these episodes. This is between episodes 3 and 4. Episode 4 begins here and depressurizes, causing deflation. Then it ends, and we have our pause building up to episode 5. And episode 5 was actually a fairly short signal in the grand scheme of the last month here. And what you can see is that there may be some minor subtle variations at the rift zone, but there is no major effect occurring in the rift zone as a result of the summit activity. In fact, even though the episodes are starting and stopping, summit eruption is considered to be ongoing. And you can see that it's taken a lot of the stresses away from the rift zones, which are showing very few earthquakes over the last week here. You can see there's still continued activity of earthquakes on the south flank, as the volcano still is adjusting at a little bit greater depths there to the overall eruption of the volcano and continued magma pressure within. So the primary hazard is a VOG. This is a VOG forecast for today, showing the emission source at Kīlauea and the weather patterns that are blowing this fog to the north and to the east and to the southwest. With the variable winds over the last few weeks, this has been a primary impact. And I can show you this more clearly from this satellite SO2 image showing concentrations of sulfur dioxide yesterday as viewed from space. Closer in, we also have Pele's hairs, these glass strands that are collecting in nearby areas. This is an image from the visitor center in the national park. And so those are the primary hazards for people here today. The USGS is able to define possible restart windows. And once again, they defined a window in the most recent USGS notice in advance of this eruption, suggesting it would occur between Tuesday and Sunday, and it did occur on Wednesday. And so the most recent update today from the USGS notes that if the current rapid rate of recovery continues, it's possible another episode could begin within the next 3 to 4 days. But more time is needed to see if that rate basically stays the same or if something will change and modify the window of start time. So that's the summary for Kīlauea over the last week. Mauna Loa continues very quiet. These are the earthquakes over the past week, very few here in the summit vicinity. Still very low overall across the volcano. Here are earthquakes per month for the last 5 years, and so here we are, still quite low. However, the volcano is still filling with magma as the summit GPS continues to rise upwards and showing how it's really swelling from within. That's our Hawaiian volcano summary for this week. You can always tell when I'm talking too fast there when it takes a while for our interpreters to catch up here at the end, but that's how it goes. A lot to get through today. All right, so let's turn to our volcanic hazard summary. And that will be leaning on our VMAP, VOG Measurement and Prediction Project from University of Hawaii at Manoa. So I showed you this a little bit in the update earlier, right? So this is the moderate threshold of 0.1 ppm, and this is, as I've said, for the next 48 hours or so. And so showing the emission source. Our rate put in here is about 800 tons per day, which is probably a decent guess for a background rate now. The USGS reports there was 10,000 tons of SO2 that was emitted. Well, it was 10,000 tons per day at the start of the eruption yesterday. The eruption did not last a full day, so I don't know if 10,000 tons actually came out or some fraction of that, right? But that's the order of magnitude of how much gas came out. So it's reduced quite a bit since the lava stopped coming out, but imagine that there's still quite a bit, and the current slack winds and variable winds are likely to blow them in more areas than usual. So this requires a little bit more observation from us today. So besides this VOG dashboard, I thought we could go to our resources. Let's see here. This is the state page, which is doesn't seem to want to reload for me here. Try to click some of these buttons. Here we go. All right, so this is the state of Hawaii air quality page, and it's trying to detect both SO2 and ppm here. And if you just look at this map, you see there's not a whole lot of stations all around, and they're all showing green, although there are some numbers showing it is not flatlined in these areas. So it's not the greatest coverage, so we like to supplement that by looking at the Citizen Science Purple Air Monitoring Network, which you see here. So still some greens, but if you see a few more yellows and certainly more of these oranges and reds, especially in nearby areas to the national park, where this wind is wafting and blowing this volcanic gas and the fog that it produces all around. So some other these measurements, I'm not sure if anything heavy is going on compared to what Kīlauea, but it does pick up all different kinds of air quality issues, right? So we're trying to piece together what we see here with what we see in the forecast and the other observations as well. We can go to the windy.com SO2 layer and look at our SO2 plume that's blowing both to our southwest and to our northeast and getting caught in this low pressure gyre right up here, which is interesting. That's part of why our winds are so wonky here in the last few days and over the last few weeks. So in the big picture, it's just a little drop in how much SO2 is around the atmosphere. But when you zoom into Hawaii Island, you can see that certainly there is an impact across the whole island here. And I thought I could pull out, this is the Mounts project. We usually look at this for our INSAR. I don't have anything new to show you there, but we can come back and show you some of these recent SO2 satellite captures. Let's see if this zooms in any more. Yeah, there we go. And show you guys, this is capture from the 19th, 17th. You can see the VOG has been different intensities, different days. Here we have our pause. But we are catching times when there's quite a bit of output Looks like my page isn't loading anything older than that, but you get the idea here of the VOG impact coming from the island on a day-to-day basis. So zooming closer in, here's the air quality at the national park. Let's just reload and make sure we're as current as possible here. So our summary is showing us 2-mile-an-hour winds, so very weak winds, and that would put a lot of the volcanic emissions kind of sitting in this area, but all the sensors are showing green at the moment in a national park. We can go in more detail to the charts and look around, and you can see that actually it's remained in the green, both for the SO2 column on this left side and this particulate matter 2.5 on the right side. Everything has remained in the green on the stations that are online here throughout the day. So it certainly can be present in areas, could be passing, but it's not picking up on the monitors. I myself was able to get out to the volcano house last night, and everything was in the green, but I still felt a little tickle in my throat the next morning, you know, so even at low levels, there can be effects there. So that's the hazard update, which is the VOG right now. Everything as far as lava is still within Kīlauea Pele, the summit caldera, which we like to call our lava stadium. It's a great place for it to be in a giant bowl. It can't escape out of there over top of the ground. And are great view sites all around if you can stay clear of the gas, right? And especially if you have any respiratory sensitivities, you want to follow the park guidance and park advice and be prepared for that. All right, so that's our volcanic hazard summary. I will switch to Volcano Watch next. The Volcano Watch this week is just highlighting the Pele's hair hazards, which are associated with the gas emissions of Kīlauea. So what we've seen with these high fountains is that the lava is bursting up and these big clots, and what happens is those clots kind of stretch out and pull apart. You almost get like a spun glass. It's like almost like a cotton candy kind of process when you have that stuff being pulled apart. But the lava, when it stretches out to that thinness, it basically hardens into a solid piece of glass that is then very light and can be carried by that thermal heat updraft and blown away with all the gas, and can land in further away places and than most of the other stuff that comes out of the volcano. So something that's happened, especially with episode 4, this last episode, was especially slack winds and a lot of Pele's hair falling around the volcano village area. And so here's an example of what they're calling a tubular tumbleweed of Pele's hair. This reached 22 inches and was 2 feet long. And you can see that where it's all stuck together in there. And they report here the strands can be more than 1 meter or 3 feet long and less than 1 millimeter thick, or 0.04 inches, or 1/20th of an inch. Normally, the trade winds blow these particles down into the Ka'u Desert, but no trade winds from January 15th to 18th during episode 4. So a lot of it fell in a national park, the Volcano Golf Course subdivision, Volcano Village, Mauna Loa Estates, Ohia Estates, all these neighborhoods that surround the national park, essentially. Right? So they actually address here. You may be wondering if there are steps you may need to take regarding vehicles, pets, and children being outside, grazing livestock, or water catchment systems if you live in an area that's been affected by Pele's hair. So they do note that much of the guidance about volcanic ash exposure can be applied to Pele's hair, although they're not exactly the same. Ash is defined as particles smaller than 2 millimeters, or 0.0, call it 8 inches in diameter. And so while Pele's hair is usually thicker and longer, here's what they say. It is likely that ash-sized particles are also falling with Pele's hair. And Pele's hair can break into ash-sized pieces. So what would you do with ash? You know, the Pele's hair itself, that piece of glass, it's not toxic in and of itself, but it can actually accumulate in large numbers to either cause abrasions, scratches on stuff, or to block maybe certain filters, depending on what kind of filters you might be using. So they do note here that the eruption deposited less than 1 millimeter of Pele's hairs in communities near the summit. This amount usually does not require any action, but it's good to be aware and prepared in case more Pele's hair falls in the future or collects over time. So they note to look at any flat surfaces outside and judge how much Pele's hair is collecting there, like on the hood of your car or on your windshield, that kind of thing. What you don't want to do is go brush it off with your hand because it's glassy. It can actually cut you or stick in your hand, right? You want to, if you can, wash it off with water or some kind of cloth or something like that. They note windows and door handles, especially, you can scratch paint and metal surfaces here. It does note it's abrasive and can irritate eyes, skin, respiratory systems. Limiting exposure as best way to avoid being impacted. So if you're out working in an area that has this stuff, wear gloves, eye protection, face masks. You can't limit exposure. Eventually, the rainfall and the wind and just crunching of it will break down Pele's hairs, and plants will bind it into the soil. We'll get Dane's feedback here in a minute as he lived through this to 2018, but let me just finish the article here. They note that the amount of Pele's hairs that fell recently was small enough to be handled by most general filtration systems. However, if you're concerned about it getting in your water catchment during future episodes, there are steps that you can take to prevent that from happening. Their recommendation is to disconnect the downpipe that connects the gutter system to the tank when the Pele's hair is falling. Right, that prevents it from going into the tank and getting into your system, into your filter. So it's still falling on your tank and your gutters, but then a rainfall or rinsing will wash it off, flush it out of the downpipe, and then they're telling you to reconnect the downpipe again. Now, I've also heard that, maybe now we'll start transitioning a little bit to the 2018 experiences, but I heard people taking pantyhose, right, and putting it in between the downspout and the connector, right? If you're just worried about the glass itself, that's something you can collect, not all of it, but a bunch of it to prevent your filters clogging. Besides the actual physical material that's falling in the tank, in 2018 we saw there was a lot of chemistry coming out of the gases themselves because there was so much gas coming out in 2018. So I'm not sure we're dealing with that so much here today in Volcano Village, but quite a lot of Pele's hair falls on the ground. And there's one thing here that they know what does it say about the grazing animals. I don't think I'm going to miss that here, right? Doesn't wash off grassy areas as easily as ash and can impact grazing animals, but there's no studies. If you're concerned, consider supplementing your animal's feed or relocating them to an area where Pele's hair did not fall. It's probably easier said than done. It does note that it can be beneficial to pasture growth in the long term. So in 2018, this lasted for a lot longer, deposited in much greater amounts. We had people going out and actually mowing their lawn, Dane. Tell us what your experience was with Pele's hair after that.
So first I have to address this and what they're putting out there, because really with the advice on the gutters, that assumes that the gutters are clean in the first place, that all this stuff just flows off the roof. That has not been my experience with Pele's hair in the gutters. That stuff stays up there. It'll stay in the gutters no matter how much rain it comes. It's not going to wash it all away. It'll wash some of it down. But when you go up there to clean your gutters, that's when you're going to find out just how much Pele's hair was out. Because if you take a bare hand and run it through your gutters after this, it's going to be a ton of splinters. And I tell you this by experience type of thing, looking in the gutter and be like, oh, that's fine. Running a hand through and like, okay, never mind, not doing that ever again. Right. I like the pantyhose idea. The pantyhose idea I do like, and even disconnecting your thing. There's some merit to that. But after you reconnect it, there's still some amount of Pele's hair trickling through the system, essentially. So
which is okay. It's not toxic in itself.
Right.
Yeah.
One of these episodes, to me, I'm like, go clean the gutters. If you really want to be, make sure that your catchment's good to go, disconnect it, go clean the gutters, make sure to wear gloves. Then you can reconnect, since we're in a pause. And sadly, I think that's what you kind of have to do if you're going to really be proactive, right? It sucks.
Yeah.
Type of thing, especially with all the corrosion.
Proactively clean them out of all the other stuff that's in there first, right? That's what you're saying too, right? That makes it easier to clean a Pele's hair by itself as well. So maybe you need to spray in there and not just let the rain, unless you wait for one of those giant winter storms where it dumps 40 inches. One of those might wash everything out, but don't hold your breath for them to happen. They don't happen every week, right?
Right. You take a sprayer into the gutters or anything like that, even the hose, I bet it would do a good job. You know, as long as you got some water pressure in there. Sorry to take a tangent on the Pele's here, but it is a real thing that people are getting impacted by. In Volcano Village, we know that people down Ka'u kind of used to it, maybe got it a little lighter this time than they're typically used to because it was going with the southern winds. But yeah, it's always, it doesn't seem important until it's important type of thing. It's one of those things. But we were mowing the lawns in 2018 to get rid of the stuff and tell people, you know, basically get out your hazmat suit, right? You want gloves, you want as much cover as you can get, or respirator, definitely glasses, you know, sealed glasses to the point of telling people if you don't have, you know, good goggles for this, go get some, you know, just simple diving stuff, right? The simple snorkel, just the mask part of it, right, will get you through this, right? And it was just interesting. We had so much more though, right?
Yeah.
And mostly it was a big mix of tephra and Pele's hair, like evenly mixed between it. This one seems like mostly Volcano Village is just getting the Pele's hair mostly, as far as I've seen.
Yeah. There's no proximity. I mean, your house is super close to Ahu'ailau, right? Like you're probably getting tephra and Pele's hair both. And, you know, maybe a few streets down from you, they were not getting as much tephra. We know they were.
And more Pele's
some,
hair.
right? But more Pele's hair and, you know, so on and so forth, right? So
that makes sense.
Yeah. For it to come out of the summit crater, I mean, it's really interesting. We've heard Don Swanson talk about reticulite, the Hawaiian pummices that are present on a summit rim, and how that must have been from lava fountains that must have shot above the rim. And he's been warning us about the fact that these are hazards that occur above the rim in Volcano Village for a while, and we actually are getting to see it here for the first time. You know, fortunately or unfortunately, right? More fortunately for the sake of science, and less fortunately if you're living in it. And it's not that bad yet, right? But it's something that might happen more and more frequently if we have fountains occurring that actually are able to put material above the crater walls. And the crater is filling up, and it's happened already a couple of times. So, you know, it's a great time to talk about it and reintroduce all of us to what that is in case it does get bad.
One thing that was interesting to me is I haven't seen many of the vortexes down on the lava lake, you know, inside.
Just wait for it.
Huh? Oh, wait,
we have a video of that actually.
I was just gonna try and tie that to the wind direction, right? These southern winds that is pushing the things to the Pele's hair up into Volcano Village. I'm wondering if that has some play. But anyway, sorry, just jump ahead.
Yeah, it was interesting because I was thinking a similar thing, and then the US just put out a video which we'll get to shortly here.
All right, cool.
But yeah, so the wind is definitely playing a big part and something to keep an eye on here. And so when another episode does begin, whenever that may be, that's when the most gas will come out. That's when a Pele's hairs are most likely to get carried the furthest, and that's when to be aware of this hazard once again. And so a little bit different order, but it was merited because of nicely on topic volcano watch this week for our hazards. And to remind you guys, our mission here at HVERI is to improve our preparedness to any situation here on the island, any disasters, improve our response through preparedness. And so this is a great educational tool to talk about this week, spend a little extra time on. But now that that's said, let's check in with what's happening at the summit. Here is a live view from the USGS cam on YouTube, showing a lot of that gas blowing right towards this camera. So it obscures a lot of the details of what's in the background. Here is the vent that was erupting and the source of all that gas coming out there. But as you can see, no red or anything really visible in there. We can look at our other summit webcams. Look at the USGS page here with the index. There is a S2 looking from the south with the two vents. The one that was erupting here on the right, the north one, and the one on the south was not reactivated during this most recent episode. Right there. The KW camera, which we see the wide view of the caldera, and here you can clearly see from right to left the direction of this gas blowing across the summit here from the vent. The current state of things, here is the F1 camera showing this footprint of the recent flow, an event from here, and it spread out off in that direction. And it looks like we have a little ooze up or a little overturning outbreak way over here, a little bit apart. right, which is interesting. We'll come to that here in another few minutes. But fascinating. That's something that maybe has changed over the last episodes from the previous ones. And the V1 camera from the live stream itself, we just saw, it's pretty vogged out right there. The B1 further back, wider view of the caldera here and a down drop block. The B2 looking closer in. I'm not sure where that ooze up flow is, maybe right there. Looks like it might be something happening right there, but otherwise the activity was all in this part of the camera recently on this view of the B2 camera. And further off, K2 from above, you see the once again a VOG blowing to the east there, to the left part of the screen. And our wider back camera from the Mauna Loa Strip Road can't really see too much of what's happening there, but maybe there's blue sky in this little triangle right here. And so maybe this is the source of the VOG blowing towards the camera and off in this direction as well. As our indicator of the directions here. So that's the current webcam views. We'll come to some time lapses here in a few minutes. But first, let's come in to look at the USGS releases. So start off with the one from the 17th. This is when we still had episode 4 going on. This is last week. And here for contrast, you see both the south vent and the north vent active during episode 4. And you also can see how the cinder cones had built up and the fountains were exceeding or reaching the height of these cones, which overall were more or less, or saying between 30 and 50 meters tall, these cones. It's hard to pin them down because they're growing tall, they collapse in on themselves, they grow tall some more, and which part are you measuring? But you can see that the fountains at that point in time consistently 165 and 130 feet tall right up there. So we'll come to some of these videos here in a few minutes, but here's a view of the S2 camera right there. So let's look at a better resolution of that right there. There's the camera setup looking in, and a little solar panel down on the side. Nice view on the edge of this cracked rock. And you see the USGS is also using that as a site for measurements. Right? You can see there's a little ho'okupu offering down here as well. So you can see that there is likely some cultural practice ongoing as well when they're coming out to these sites. They don't share quite so much, but they are respecting that. Yeah, and have shared a little bit about that in the past, but they don't really highlight it too much. So let's come back to our index. There are different views of the close-ups of those vents and the cones building up, and the work that you do with laser rangefinders, what it looks like from the ground on a cracked road just above there. They've actually launched UAS drones to both assess volcanic gas emissions and take aerial imagery to aid in hazard assessment there. So the Pele's hair on the ground. A view from above, there's a piece of crater rim drive that's collapsed partway down into the crater, viewed from that south part of the crater. And from above, this view, this is one I like. Let's flip over to this. Oh, Pele's hair, and over to this. View all the tephra, all the fallout from the fountain that's collected on the road since this eruption began in late December, 1 month ago. So you see there, it's covering a lot of the road. There's some little high spots in it, but it's filling obviously everything all across this whole area. But it's easier to pick out how much it's collecting on the road itself, right? Because you can see parts of the road further to the east and further to the west that are not quite as covered there. So pretty interesting to note. This is a couple areas of where the southwest rift comes in. Right over here, right? There used to be a little sign. You can stop here at this pull out in the southwest rift before this was all closed and back in 2008. So there's that view, more of a ground level, low angle view of those fountains. Both of them active there. And a couple of videos. Let's come to the videos here. First, we'll show you this one. This is from episode 4. You can see the view from above, both fountains From this perspective, the north mountain is on the left, and the south mountain on the right. You see spitting these flows. They're marching across the crater floor and moving on through various rapids and filling in big areas of the crater floor. There's another branch coming off this way. There's a branch coming off that way. It's really all over the place. Nice reverse angle. You see there's a standing pond of lava shooting up and through. If the sound would come through, you guys could hear the roar. It sounds like crashing waves almost, or almost like a jet engine, or a bunch of jets making noise over each other. See the lava landing up on a rim and causing splashes, but when it's doing so, it's actually cooling and solidifying and adding height to these cones. That's how these cones actually grow. So great view of episode 4 there. And so there's our view of the southwest part of the crater. Here's the crater rim drive where it comes in. There's that little piece of the road that's stranded on a block partway up. The fountains in the far southwest part of the crater, sending flows all across to the east here. You see some fuming spots. You only see a little bit of this remnant of this degassing area over here where we have mineral deposits, because much of this was, or all of this was flooded with lava over the last few weeks here. And so only where you still have degassing do you see that coming through. But that marks more or less that side of the central island that's buried underneath there right now. A more vertical view of that piece of road right there. And finally coming around into view is the June 2023 cone, which erupted way over here. And at the time it was on a downdrop block and flowing into the main crater. You see all of that's been buried too, and not only the cone is visible above that lava flow. Here you see the USGS scientists landed on that downdrop block at the far end of the crater, where they know that this ground over here is more solid. And they're looking at these ooze out of Pahoehoe lava flows. This looks not too unlike what we'd see down in Kalapana, in the area of the ocean entries down there. And this is great because this is a great kind of flow to go and sample. So here they are taking lava samples to determine the chemistry of them. Right, and this is something we'll hear more reports on in the future and discuss in greater length. But for now, they're collecting the samples, ideally from every episode possible, whether it's by actually going down and collecting it with a shovel or a hammer like this, or possibly collecting bits that shoot out of the fountain and land on a road or on your car windshield that you know that was landed while you were there. So it's from that eruption. So that kind of thing. And you can see they're also here scouting. They're flying off of that downdrop block area, checking out these cliffs of the collapse. You see some of these have quite a bit of discoloration and areas where there's been venting and degassing and mineral precipitation. You can see there's quite a lot of topography. Like it looks flat from the map. When you look in detail, there's a lot of really bumpy ground from where the lava is still on the edge of over here to get up this remaining slope towards the cliff of the downdrop block. And so now we're up above that cliff and flying back towards the fountain. This is what it looks like to be right at eye level with that piece of road that's stranded on that block right there. Yeah, lots of gas coming out, you can see here, and blowing off to the north and east there. That's that episode 4 that put all this Pele's hair and gas towards over the island and areas nearby. All right, flying over that piece of road there. And I think we're going to come at a final close look at that June 2023 cone, which is right there, right, in comparison to the ones we have building up now. So our double cones from our double fountains here are both bigger than we had in June 2023, as you can see, right, which makes sense because the fountains themselves are higher, so it's depositing stuff higher and building a bigger pile around the vent. So nice aerial views there, episode 4. There's that cone right against the crater wall right there. You can see nothing around it except the flows from this current eruption over the last month. And that's the aerial video. And they actually were also down on the ground for this, shooting on a tripod, looking at the fountains themselves. So let me switch over to that here as I fly up above the rim. I'm going to wrap up this video here. And actually clear air towards Kau. And here is the video from the ground. So there you see the double fountains, the cones growing. Look at this piece right here. It's about to fall in. And sometimes they fall in just from being over steep, where there's too much stuff piling up and it just can't support itself. The stuff is all gooey on the inside. You can see what's left of the scar right in here. So it can be moving and sliding under its own weight, right? But also if the lava pressure coming out of the hole varies at all, let's say it drops down a little bit, then that can take away some of the support that's further down against the wall of this thing, and that can cause this series of collapses as well. So often what we see and what we saw as episode 4 ended was the magma column withdraw and the cones collapse, block off, and then ultimately stop erupting. And so at the end of episode 4, we actually saw that happen with the south vent, where the north vent lasted a little longer. And so when we saw episode 5 begin and it was only the north vent, maybe there's something connected there where that drained back and collapsed at the end of episode 4, which is still active in this video here, led to what we saw as far as the character of episode 5 being only in the north. It's hard to tell the scale here, right? Remember they're saying that these fountains are 150 feet tall, more or less, 100 feet tall, somewhere in that ballpark. So this would be the height of a 10-story building. And that would be like a, not sure what class rapids, like flowing out of that lake in there, down into the main part of the caldera. You see how the flow is actually splitting around this little island here that maybe is a piece of all the spatter, which is usually a little bit frothier material. It traps more gas within the rock, so it can float a little more, and that means that it can actually, if it's a big enough piece that's sliding into this lava flow, it can become a little island. Here you go, Dane. Here's a zoom-in view that USGS released. There's flow moving across the screen all in this way, all through here. But then right in here is our little lava NATO, as we've called them before, a little wind vortex that's ripping up the crust. And for anyone who's curious, how thick is the crust, right? There you can see there's a piece just flew off, landed in another piece, and burst through it. So you're looking at a few centimeters, a few inches only, something like that. These things are flying around like leaves almost. So even though it all looks pretty silvery and not red here, you can see from this little vortex what it really is underneath that very thin crust.
And with this video, one thing that it helps give me clarity on is, remember in 2018 we saw a lot of these things. They were pretty cool, and videos all over of them. And then we were all happy about seeing them. And then one day they threw the material outside of the channel and started that fire. And it was like, okay, suddenly not so cool and actually kind of dangerous. But down in the caldera here, no chance of that, right? It was only that one specific instance where it was like, 100 yards from or 100 feet from the channel to the vegetation or something like that where it happened. If I remember right, it was a while ago.
Right. Let me pull us back and zoom it in case, because I know it's kind of small on the screen there,
but those are flying
really
a good distance, like those pieces that we see there.
Yeah, so it's really showing us that this is a not just a lava flow, but a big pool of massive pool of material that's all molten underneath this crust.
Right.
And see how even over here where it looked like it was solid, that little vortex just marches over, and it's also getting ripped apart. And look at that piece over there splashing. Yeah, it's really, really cool. And you see the whole thing.
And even that looks like it's somewhat solid. Nope.
Yeah, you see almost like coils on the surface there, right? But they just fly right off. Yeah, so that's why this whole area, even though it looks silver in the daytime, at night can really glow and be really bright. There's hardly anything blocking the inside of the lava from the outside. It's enough for daytime, but not enough for nighttime. So that was our tail end of episode 4. And we do have another release from episode 5 here, which was much briefer. So I showed you guys this video at the start here. Once again, you can hear the sound and like roaring, surf crashing, jet engines. Here's our south vent, fuming profusely, and big splashes here up the north vent, filling this place around. Really spectacular splashing. You can see that the height of the cone is somewhere here, and that's about how high we have the fountains jetting as well. So maybe a little bit smaller than previous episodes, but still on the order of 100 feet or so. And you can see with still big rivers of lava flowing out from here and flooding the southwest part of the crater floor. And there's a view through the telephoto lens. Just to show that the detail. Look how many streams of lava are coming down there, feeding these different channels and flows, all leading into the crater. A view of the sunset. You can imagine there are some amazing views USGS is sharing with us here, which is really great. And silhouette of someone appreciating that beauty in between those moments of work there. And that's the update of visuals for today. So what we'll do is go to the time lapses now. And what I thought I could do with the time lapses is we'll put together both of the last two episodes, and that gives us a little bit more reference. So our time starts here back on January 14th. And there we go. The eruption begins on the 15th, episode 4. There it is. Put out that flow there at the bottom. It starts marching across the caldera floor, that inner crater. Start seeing ooze-up flows further afield from the main flow as well, early in episode 4. See, they're all the way out there, but massive flows coming from the vent. It shuts off. The flow still moves a bit, still overturning. Then we have our pause. 4 days of pause between episodes 4 and 5. Shutting off on the morning of the 18th and beginning in the afternoon of the 22nd. In between, events still glowing, and there it comes bursting out again. So relatively speaking, pretty quick. By daybreak, it's over, overturning, and not much to see except gas now, as we saw in the current webcam view. So the F1 camera, thermal camera, over the same time frame, picks up similar stuff. Remember we were talking about this old lava pond from previous eruptions, refilling from below here and subsiding during the pre-episode 4 build-up stages. So here's where we pick up. Episode 4 is going to start, and we'll go through that same sequence again. Okay, here comes episode 4. Starts off in the southwest, starts marching across a crater towards the east, but then we start having ooze-up flows. There they are once again, all disconnected from the main flow further afield, at least on the very surface, right? It's not quite clear. It's connected somehow, obviously, but not over the surface where we can see a clear heat signature leading from one place to the other. So here's our four-day pause. And on the 22nd at 2:57 p.m. is when this eruption begins. This last episode begins, episode 5. There it goes, bursting out, ending quickly, overturning, and then here looks like the beginning of maybe one of these ooze-ups once again. So pretty fascinating to see that. Let's check out the S2 camera view. And once again, both eruptions. So back on January 15th, there's a double fountain, episode 4. And if you look closely, you can see these cones growing and collapsing themselves all through here, and bits forming outside of the cones. Everything subsides and sags when the flow stops. Still glowing, still steaming in between, right? Indicating lava was close to the surface, and here it comes again. But short and sweet, and there we have our current view from the S2 camera. So one last time-lapse camera for today. We'll go to the B2 camera. And once again, from both these eruptions, here's our vent glowing before episode 4. There's episode 4 starting. It starts off in the southwest far part of the crater, but it's going to start marching across. And here we go. Here's the key moment. Watch this. Flow coming across the crater floor here and swelling up. And here we see the ooze-up flows here on an outboard. Right. There is our pause coming through here. Everything's pretty still, at least in this perspective during the pause. Here we come to the 22nd, where episode 5 begins. There it is. Doesn't make it quite as far across, but if you look closely, there was a little bit of movement right here at the end on this in this part of the screen. So it's pretty hard to see that. I'll show you guys in some different ways. First, what I'm going to go back to is for this whole eruption. We'll play it all just in a second here, just to show you guys real quick how this crater floor has changed just during this eruption in the last month, right? Both from lava being in place and flowing over the area and adding depth that way, but also you can see here from this last couple stages, there's like a 2-stage swelling and cracking of the crater floor that's lifting up these lava features coherently all the way up, right? So and if you look closely, it actually seems to begin over on this side, and the wave ripples across the crater floor all the way over here. Yeah, and you can see that process pretty clearly for the whole last month. But what I want to do here is let's come to my video player where I can actually control frame by frame. And here we are. This image was taken at 1 p.m. today. And I'm just going to compare it to the one at 1 p.m. yesterday. There and there, right? There's the 22nd. So I'll just go back and forth here. And you can see that crater floor all the way over here in front of the B2 camera, where lava did not flow during this episode 5 at all, has lifted up. Right? So that happens just like we saw in episode 4. I'll play this once again. Let's pull it back here to the beginning of episode 4. Very soon after we see this injection of lava under the surface here, the fountains shut off not long after that. So here comes the fountain, here comes the flow, the fountains decrease, here are ooze outs, that's the nighttime, and here's the next day, they're shut off. Just like that, the eruption is over. So coming to what just happened now, what happened a lot quicker. And here is episode 5. It shuts off, and you're still seeing this last bit of crater moving up and down. Off the screen there, as you can see here, right? The last 2 days. So before lava came out and after. So hopefully that's a little more clear there, right? And sometimes we see these ooze outs, like we saw before, coming out from this edge, and they're flowing into the trough that's around this uplift. So it's not quite clear exactly how deep this injection is happening. If it's happening very deep, or it's happening a little bit more shallowly, it could happen within the lava flows that have occurred over the last month, is a likely possibility, because you see this whole area injecting. But it's not quite clear exactly where it is, right? There's likely like a layer cake of lava flows that are hard and still gooey within this pit. And something interesting is happening without being able to describe more accurately than that. We can see that there's certainly movement of the crater floor here as the eruption ends and the fountains shut off. So a little nuance there to look for, because we've seen that USGS, through their monitoring now, has been pretty good about being able to predict a window of time where the eruption is most probably going to restart. So we can look at that a little bit next here. Let's turn to our monitoring on Kīlauea. So I'm going to start off back on January 18th, when episode 4 actually ended. And that's what's reported here. And at that point in time, let's see here, the next day, what you're putting out now is, for example, on Sunday the 19th, after episode 4 had ended, they're coming and noting in the analysis area how much tilt has accumulated in the area, right? And so here's what they're noting. All the episodes thus far began after the Uēkahuna tilt meter recorded between 6 and 12 microradians of inflationary tilt. So it's not a hard line. It's like a move, kind of a bracket of a threshold there, like somewhere in that range. And they note that it gained 2.5 microradians of inflation within 24 hours previous to this report. And it's inflating at a rate of 2 microradians per day. So if that were to be the case, You can see back on January 19th, they say the 5th episode could begin between Tuesday the 21st and Friday the 24th. And lo and behold, it began on Wednesday the 22nd. So that was right on, right? They note if the rate of inflation slows, the probable window of time for resumption of activity would be longer. Right? So they actually called that there. I'm going to kind of just jump ahead here to, let's come to Tuesday, let's call it. Let's go to here, Tuesday, and to the analysis section once again. And so here they say they have 6 microradians of tilt in the 3 days since it ended, continuing to inflate at a rate of 2 per day. And so they still keep to that window of January 21st to Friday the 24th. By Wednesday morning, the tilt actually slows down a bit. So let's make sure this is Wednesday. Yeah, here's Wednesday. And they note the drop in inflation rate, even though strong vent glow continues, suggests the window where episode 5 is likely to start. It now extends, right? And it goes from Tuesday through Saturday or Sunday because of that slower rate. And here's our caveat, right? The probable window of time is based on behavior prior to previous episodes. And the caveat here, it could be longer if the inflation rate slows or if more pressure is required to initiate the next eruptive episode. So that's how they're going at it. And they had this graphic in the Volcano Watch last week, right? So for example, what they're talking about is, you see here, this is the tilt meter on the ground. And so the episodes are marked episode 1, episode 2, episode 3, and it's kind of salmon color here in the background. And you can see that they got longer and longer as far as how long they lasted and as far as how much pause there was in between them as well here. But even then, what they're doing is they're not counting it by time. They're using this threshold of microradians over here. So they can see that, okay, if from here to here is 6 microradians, and that's when it began again. And when it ended from here to here was 6 microradians, and then it began again, right? And so this last one actually might have got to 12 microradians, and you can see it's off to the right here. But because it's inflating at a slower rate, that throws off the timing. So that's why we had a 12-day gap here between episode 3 and episode 4 right there, right? So that's why it's so interesting to note how reliable this is. Even though the periods of time have varied, they've still maintained this correct, they hit it again for episode 5 and 4 now. This window of time, one episode would actually restart, right? So even though it began only 4 days after the last episode, that was what they had expected, right? And forecast as the most probable window of time for that to occur. So with all that said, if they got that good at it, that's why it's interesting to come to the update from today, from Thursday. And we can go a little bit more detail with what's happening here, right? They noted the actual times. The episode 5 ended at 4:30 in the morning this morning. It was after a little less than 14 hours. It seems like there's a typo here in their text update. They note the SO2 emission rate of gases of 10,000 tons per day of sulfur dioxide. Note everything is, the glow continues. All the other monitors are behaving as expected, to keep it brief here. They did note that Pele's hair was observed at Steaming Bluff Car Park overnight and maybe continued to remobilize by winds within a national park and nearby communities over the next few days. So that still remains a hazard, even if it's not putting out gas, not as much as when it's putting out more, but it can blow around as well. All right, so then coming down to, importantly, there is no major change, no unusual activity in either the East Rift Zone or the Southwest Rift. That hasn't changed since about a week before this eruption began. Seismicity is still low there, deformation is still low there. And so for their analysis, they note here, in the 3 hours this morning between when episode 5 ended and this update came out, they recorded 0.2 to 0.3 microradians of inflation, which is a rapid rate. And already they say if that continued, it's possible another episode to begin as early as the next 3 to 4 days, right? So, but if it slows down, then it would actually be longer than that, is what this rest of this text is saying here. So we had a suggestion to do an over-under and when the next episode might restart, huh, Dane? Here's a USGS 3 to 4 days. What do you think?
I'm probably gonna go with the under. It seems like with the last episode, with only taking 7 microradians of tilt before it popped back up within less than a week. It's like that thing's just open, like open. All it takes is a little gas bubble to come up, and boom, we have a new episode type of thing, or something. I don't know what the threshold is, right, on that. What makes an episode on the low side, but it seems like within the next week. But let's look at what we got so far. Right now, we did post the poll just 5 minutes ago, so if you haven't voted on it, go ahead and take your, it's on YouTube. It's only on YouTube, the poll. But will episode 6 start on Kīlauea by next week at this time? And 85% of the viewers think it will be before next week, Thursday, when we go live.
Oh, interesting. We'll see if that holds, right?
Right.
And the other question that might come up, which is a lot harder, just totally a shot in the dark, is how many episodes might there be? How long might it actually go on? There's no real answer to that. We talked about how Pu'u'o had more than 40 high fountain episodes. Manaulu had more than a dozen. I put up this graph of Kīlauea before, right? Kīlauea had 17 episodes over the course of about a month. So here you can see that their first episode was the longest, and then they got shorter and shorter and shorter, right? So there's all different patterns that can occur, and it's hard to say it's going to be this way or going to be that way. It's just wait and see what happens.
Out of curiosity, can you maybe talk about just like the episodes on Pu'u'o, and like, because we have G's and letters getting thrown in on top of the number. Now, right now we're just doing episode 1, 2, 3, 4, 5. When does it start getting more complex type of thing?
Yeah, so it's the history of Pu'u'o is too much to get into at this point in time, right? But there basically were several phases. There was a high fountaining phase that lasted from the first 1983 to 1986. Then it shifted to Kupainaha, where then it formed a lava lake and pahoehoe flows, and so that's when it kind of shifted away. When it came back to Pu'u'o, it was no longer fountaining, but it was coming out of the vent and producing flows as well, right? You'd have smaller fountains, but not high fountains of the order of more than 1,000 feet high, we'll call them, right? So it was about the first 40, I forget, 43, somewhere in there in the mid 40s of actual high fountain episodes of Pu'u'o, right? So those are the ones we refer to, right, as we're talking about the episodes. And then beyond that, they kept going, and they actually, depending on how you think of it, like different eruptions. The eruption in the Pele crater in 1997 was episode 54. Even though it was in a different place, a different crater, because Pu'u'o resumed after the fact. And so there is a little gray area in how you name things and what you call it, the new eruption phase of the current one. So usually, in my experience, the vent itself is one of the determining factors of what you call the episode, right? Is it start and stop? But if the vent moves, then that's also a new episode. Right? But if the vent doesn't move, but the flow that it's producing goes somewhere else, that might start adding letters to the episode.
Oh, okay.
So instead of having episode, right? So let's say lava's coming out of Pu'u'o and it's going towards the national park to the southwest. That might be, I'm just going to pull a number out of, let's call it like 56C or something, right? And then if that flow shifts east of Kalapana, and it changes the impact zone and changes the dynamic, then you might say, okay, or let's say leaving the cone in a different spot, possibly. That might be how you might qualify. Okay, now we're going to go to A, B, C, D, E, F, et cetera, right? Because you didn't have a change in event, you didn't have a whole new fountain episode, you didn't have a change in the location, but something did change that you're trying to document, and they're kind of painted in a corner, for lack of a better term there, right? Where you had already, we're still on episode 56.
So you need something else at that point.
How do we keep dividing it from there, right? That's my personal view, and it's something we could ask USGS, but that's how, if you look at the records of how what was classified, how it actually looks to be laid out.
All right, thank you.
Yeah, so who knows how many fantasy episodes we'll have. What we can say is compared to Kīlauea, we've gone a whole month already now. and we haven't had nearly as many episodes, and they've come into different kind of spacing. Also, ours haven't been as high, right? Kīlauea shot 1,900 feet high, 580 meters, which is just ridiculously high. That's the modern record of Kīlauea. So some differences quite, as well, and not to get into all the chemistry and the sources and all that, but just to kind of keep it on the surface of how many episodes, just some guidelines here, right? It's not likely to be 200, but it might not be just 5 either, right? So we'll see where that takes us. Okay, so let me keep going into monitoring here. Let's look at what our tilt is doing right now, right? So here we have the signals for the last week. Let's look at what's useful here. The tilt, here it is. What we see was, we'll call it close to 1 microradian when it turned around this morning. And now it might be at, well, maybe 2.5 or something. So it looks like, if anything, the rate has not changed at all, right? It looks like it's fairly linear here with a little bit of wiggle. Zoom it in more for those with small screens. But yeah, it looks like it's fairly steady, right? So I think that forecast is probably still what they're holding to, 3 or 4 days to the next episode. Earthquakes are occurring here, but at fairly low rates, almost like the background rates here. This area across all of Kīlauea is, I really got to show you the map here. Right here are the earthquakes, still some happening around the summit. You have your deep cluster in blue at Pahala, and a little bit deeper at the south flank here, base of the south flank, as this area, mostly in here, but this looks like a little bit off in this direction too. Seems to be adjusting to the changing pressure and stress on the volcano. It can go both ways, right? It can be like when this thing is swelling up, it pushes on the rift, and then when it's erupting, it kind of sags away from the rift. And so either way, it can relieve pressure, and the magma is moving through the rift zone at depths that are shallower than the south flank itself. And the south flank earthquakes at the base are a little bit deeper usually. So you have all kinds of adjustments happening throughout the whole stack of the volcano. It's hard to describe it in 3D here, but so that's what you see ongoing. This moves fairly regularly, at least in our lifetimes here. So this happens even when a volcano is not erupting from its summit, but that it continues to do so is telling us something as well. So that's the earthquake pattern. As far as the crater elevation, this is the one site that's near that old lava pond in the western part of the crater. And you can see here the episode 4 gain in depth, especially in that area, and then this kind of cooling and sagging as usually gas escapes and the whole lava surface sags back down and loses some of that depth. And here it is, episode 5, a little bump coming up, and then we'll probably level off and tail off down as well. So earthquakes for the last month. You can see there's not exactly a clear pattern from what you see on the graph here to where our episodes are actually occurring. So it's mostly because these earthquakes are happening not so much under the crater, but elsewhere in the volcano on the south flank, and are more independent. It's not always what we see, but that's worth pointing out when it happens as well. So there over the last month, you can see there's the drop from episode 1, or that's episode 2 actually, looks like, yeah, episode 2, and then 3 coming down, and 4, and there's 5. And so you can see that it's how much we're gaining from the lowest point, and not an absolute threshold and at the top. Like, it's not we have to reach this point and we'll erupt again. So we're not reaching anywhere near the same absolute threshold from before. It's a relative thing to where you end up when the lava stops coming out. And so that's why the rate matters. It can make it take longer or not so long if it's a little bit steeper there. And so that's the summit. Here's Sand Hill, which is showing the South Caldera and the Halema'uma'u, and you can see the patterns are pretty similar in both here. Everything's acting in sync within the summit. It's not always been the case, but it is now. And you can see here's the earthquake counts per week over the last year. So here you can see more clearly since the buildup in December, which was this, how the earthquake rates have really dropped off relatively to that. Our GPS is measuring distance across Summit Caldera north to south. And you can see when lava's coming in, it's extending, the line's going upwards, extending a lot during an intrusion or as we in place a dike to erupt. And then as the pressure is relieved and the magma comes out and the gas as well, then it can kind of sag and the two sides can contract back together. And the line goes down. So there's down again and up and down. And so here you can see we've actually sagged in net from where we were last month, but we're still going through this adjustment, right? Where in between episodes, we're extending as magma collects, and then during episodes, we're dropping back down again. These only put out one data point per day, right? So our episode 5 is going to show up as just 1 point somewhere in here and might even look like some of this noise. But that's the scale of this particular graph. And on the rift zone, Middle East rift zone by Pu'u'u, there is some wiggle in there as well, but if anything, we're seeing contraction and some adjustments going on here. And as I said before, it's likely from the pressure release of the rift zone because the summit's not pushing on it the same way as it was before. And so that's our Kīlauea signals. We'll scroll through these 5 years here, just if anyone is curious about those, but move on from there to show you guys a little bit some of the other tilt that's happening, since we haven't covered this in detail in a little while. We showed you guys summit and the rift already together. Kīlauea Iki, you can see, is following that similar pattern as the summit there. Everything is in sync around the summit, as we mentioned, from the sand hill plot. The escape road has got more of these daily variations, and it's got some funny orientation here. But if you look at the green line, and the green line is actually like the blue line. Currently, the blue line flipped over is following a very similar trend to the green line. They're almost mirroring each other there. Right, so the green line is following that same pattern as this green line up here, more or less, right? With those little variations within it. So maybe something else happening within here. And let's look to see what that might be. We come to Pu'u'u, and the blue line is the one that points closest to the rift zone right through there. You can see overall deflation, maybe a little bit of a wiggle coming up here, but pretty minor. You've seen these little wiggles here before, right? We talked about this possibly being some of that adjustment as well of other parts of the volcano to the summit, swelling, pressurizing, releasing, pressurizing, releasing, pushing, letting go, pushing, letting go, all that. So that might be happening again here, right? And also you see these little pulses where it looks like there's a little bit of inflation to the west of Pu'u'u. And this is the signal component we were looking at before to indicate the Makapui Reservoir, the source of the magma storage that caused eruption in Nepal in September of last year. So that's something to keep an eye on as well. So nothing conclusive here, right? But you can certainly see that there is adjustments happening still in that area. And further afield down at Janaka, you see just the non-magma changes. There's some funny wiggles here, but this is what you also can look like without anything happening volcanically. There's no earthquakes close by. There's nothing else happening in GPS. So this is just what a signal looks like for background. Right? We're looking at all the parts of the toolkit informing us together what's happening in an area, not like any one by itself. Right, so that's our tilt, and I think we will just play. We're talking about the rift zone here. Would like to play you guys just a short clip from Volcano Awareness Month here. This is going to be, what is it, about 1.5 minutes of Dr. Ingrid Johansson when she was at the Pahoa Library last week.
Live.
Oh, so I'm going to get this proper place. And let's let her just give us a little update about what's happening on the volcano and more particular in the East Rift. So here it goes.
2024 has been a really dynamic year at Kīlauea Volcano. We've had a major intrusion in the Southwest Rift Zone, followed by a short-lived but really interesting eruption out there on June 3rd. We also had a series of intrusions into the Upper East Rift Zone and an eruption out at Nepal Crater in the Middle East Rift Zone. And then we wrapped up the year with our 6th summit eruption since the end of 2018, which is currently in a pause state, maybe ready to get restarted. So far, all the East Rift Zone activity has been in the Middle East Rift Zone. We've seen filling of the rift in that region to feed the Nepal eruption. We have not seen major deformation or seismicity down rift of Pu'u'u. So far, no signs of activity anywhere downrift from Pu'ua'o. That said, things can evolve quickly. And it is interesting that activity has moved out of the summit this year for the first time since 2018. So we're going to keep our eye on where things might be moving in the future. And everyone should be aware of the hazard where they live, regardless of what's currently happening in the volcano. So please be aware of the flow hazard where you live.
All right, mahalo to the USGS for giving us that short interview. Where otherwise there was some issues in getting that filmed in the library there in Pahoa. Yeah, so the reason we do this is to continue our awareness of of these areas that can be hit by eruption following 2018. Everyone knows that the Lower East Rift is one of those areas, and so we know someday there will be impact there again, and that's why we are doing this massive education campaign, both to help us understand what's happening in the wake of 2018, but also to prepare us for anything that happens in the future as well. So it is really important to be educated on these things and to talk to your neighbors and your community members and just know what's real and what isn't, so that if something does happen and there's fake news, for example, then you'll know where to turn and how to filter information and understand what's really important to you. That's what we're getting at long term here. All right, so that's just a little bit of volcano awareness. We're going to finish off here with earthquakes today. So let me put the earthquakes on the screen here, and we'll show you guys. These are earthquakes colored by depth. So the blues are deeper than the greens, deeper than the yellows. Next comes orange. Reds are the shallowest here. So over the last 2 weeks, here's a map of the island. You see a lot of events surrounding the volcanoes that are the background settling events. You see this population of blues all through here. That's the hotspot feeder underneath Pahala. The earthquake storm has been happening for years there. Not a whole lot on Mauna Loa. You see there's a 2.5 off to the side, just one adjustment. And not a whole lot on Kīlauea either. The most adjustments happening here in the south flank, 2.1, 1.8 there, and 2.9 a little further off over there in the last 2 weeks here, right? If I go to the last 2 days, it's much quieter all across there. So looking at this a different way, here are the earthquakes colored by time. So now we have the last week is yellow, the last day is orange, the last hour would be red. There's no red on here, there's only one orange, so that's showing a fairly slow rate coming through here. Right? But the most recent event we've had is the Pahala 2.8 within the last 7 days. That is the largest event that we have here. So not a lot happening earthquake-wise. However, as a final little twist this week, the USGS did put out a status report yesterday on 2 days ago on Tuesday on Kamaehua Kanaloa, the volcano formerly known as Lo'ihi Seamount. And they note that there was a period of seismic unrest around 2 o'clock in the morning on Monday. Well, they say Monday, the 21st. Seismicity ceased by 8 a.m. So between 2 a.m. and 8 a.m. And continuation seemed unlikely. We haven't heard anything since then, so we presume it's over. And we have to rely entirely on them because here is what it actually consisted of. 16 total earthquakes, all with magnitude 0 and smaller at depths of 8 to 20 miles below sea level. No felt reports, and because they're so small, they're not even going to show up on our map. So, but we did have this report, and there it's noted for Kamaehu. So that is our earthquakes, and I think we'll just wrap it up there. We kind of covered Mauna Loa is pretty quiet, so our summary at the top will serve well enough to tell us what's happening there. And with that said, I'll pass it off to Dane and Lou here.
Right, thank you, Phil. I'll go ahead and get Lou up on screen here. Hey, Lou, how you doing?
I'm doing good.
All right. Got a little activity for us? here?
Yeah, I do. I was just still absorbing all of that information.
There's a lot going on, huh?
There is. I'm going to take us up into the park and see what's happening around our neck of the woods here. Here we go. We do have alerts and conditions still all pretty much the same up there. The one thing I wanted to bring up tonight was with the eruption, never enter closed or restricted areas. Established eruption viewing overlooks are in place for your safety. I have a map here. We talk about all the time where the viewing is. And you can see down in the bottom here, got the volcano, the eruption location, and the 3 spots that are pretty much the best to view. You can't really see anything from the Kīlauea overlook. So a little map to help you guys out. Down at the Devastation Trail parking lot, I'd also like to know people are trying to park off-road. The park says, please don't park off-road unless a ranger instructs you to do that. Nene are nesting. It could be just a drop-off, so pay attention up there. I did throw some tips up in case you are new to the park and you need some information or just a reminder. My big one up there is bring a flashlight. Bring a flashlight. And safety tips, know that there's people everywhere walking. So I just wanted to bring up those important things in the park. It is busy. There's a lot of people, tourists, locals, a lot happening with the construction. All the roads are open.
Just throw out there, though, also, if we do get another episode and we get the fountaining, peak hours are going to be in the evening, right?
Every
And
time.
if you go there in peak hours, expect no parking. Expect
Right.
it to be busy. Expect it to be crowded because it's going to.
Yeah, and that's why I bring up just don't pull over on the side of the road. Stick to a
Right.
parking lot unless directed to park somewhere because there are nene nesting up there. Everything is still the same with all the construction. It changes daily with what they're doing up there and weather. So pay attention to the detours. There's a shot I got of the boys working. And we're still on schedule for the Kīlauea Visitor Center restrooms and adjacent parking to be closed for renovation on February 17th at 5 p.m. That's still holding. And we are in the last week-ish of Volcano Awareness Month with USGS. They had a load of them. You guys, we just played Ingrid from USGS HVO. There's the calendar of what's going on. And tomorrow we will be attending the Geology Club open house at the University of Hawaii Hilo. Come see exotic rocks and minerals from Antarctica, Africa, and beyond. I thought this was interesting as well. Bring along any neat rocks you have for UH Hilo geologists to identify. So that's pretty cool. That's tomorrow night between 4 and 6 p.m. The University of Hawaii Hilo Geology Department directly across from the YMCA. Also on Saturday, there is a big hike. This is a 3-hour estimated hike. It's rated as a moderate, so if you have any difficulty hiking, just know that it's going to take a while, and it's 4-mile round trip trail. It's going to be pretty good. The University of Hawaii Hilo Geology Department, Rick, and HVO geologist Natalia will be doing that. That's 25th at 10 a.m. And there is no after dark in the park, but the Liliuokalani at Washington Place on Saturday, January 25th at 11 a.m. We have attended and filmed presentations by Jackie. She is the director. She does a wonderful job. Jackie Pualani Johnson. She commemorates the overthrow of the Hawaiian monarchy in January 1893. There are 2 performances. So if you missed this one, there will be another one. That's 11 a.m. down at the Kahuku Visitor Center or station. And if you're not subscribed to our newsletter, there is the QR code. I also have it in the chat. You can scroll up and find that in there. Please subscribe. We put out a newsletter at the beginning of each month. Keep you updated on our outreach programs, our digital resilience, our volcano education, everything that we're doing with the nonprofit. And take it away, Dane.
Yeah, just want to thank everybody for tuning in today. Rely on viewers like you to get this information out there, like subscriptions and shares. I know everybody says it, but it does help on all the different platforms. So appreciate your support there. We also appreciate the support of I was just getting to that. The Kīlauea,
Sorry, Dane.
the Kīlauea recovery team and the Hawaii Community Foundation. Appreciate their support there. And yeah, we did have a donation come through. Wanted to highlight from Desiree. It says 20 for 1999. Mahalo for all you do to keep us connected. The beautiful Big Island. I appreciate the support there.
And we also had a $26 donation over on our donation site at hveri.org/donate from Katrin. So thank you very much.
Yeah. So yeah, we appreciate everybody for turning out today and being able to provide this. And I think with that, is there anything else we need to?
No,
we
we
can
covered
move on. All right. We'll get back Phil in here. Appreciate you, Lou, jumping in with us.
Absolutely.
All right. And we're back.
Yeah, interesting. Yeah, the park's definitely been busy.
How busy was it last night when you were there?
Last night was actually not very busy at all. I was pretty shocked, right? But it may be because the word didn't get out quite so fast, and it was only the first night, and not the weekend. Yeah, I'm not sure, but yeah, it was actually not as busy as I expected. But it's also a little bit foggy, right? So the fog was blowing more in the direction of where people were standing. So, but yeah, I found myself when I went for episode 4 that I think I arrived somewhere around 7:30 in the evening, and I had to wait for parking. But when I left by 8 o'clock, there were plenty of spots that one particular night. So it can really be hit or miss. It depends how much word is spread, how spectacular it looks, that kind of stuff. Which was a bog? How free are you? Is there a school or doctor the next morning? That kind of thing. Yeah, that's great. Great to hear that. People, great viewing up there as well.
Well, we do have some questions if you want to do those.
Yeah, let's discuss a few questions and wrap it up and get out of here.
Yeah. All right. So this one was kind of already answered, but there was one particular thing about it that I still wanted to ask you about. So Bill asked, does anybody do chemical analysis of the tephra? We know that they do, or the Pele's hair to get useful information about that. I haven't heard analysis on Pele's hair being done. I know they do it on the tephra, which is basically the same chemical signature. Is that correct? But
yeah, so the thing is, the Pele's hair, it's so small that you're not likely to have anything but the actual volcanic glass in it, right? Whereas a piece of tephra is going to have that glass, but also you might have olivine crystals in there, and the olivine crystals tell you a whole bunch more. The glass tells you something, but it tells you something in combination with what's happening with the olivine crystals and so on and so forth. So yes, you can do something with the Pele's hair, but not as much as you can with a piece of tephra that has an olivine crystal in it. Is, I think, how I would put it, right? And I'm not the expert. I'm just trying to interpret based on what the USGS has put out and all the different techniques they've shared with us over the years here. I think it's a great question. It's more like just how small and just the nature of how it forms. It kind of filters that stuff out a little bit. Yeah, maybe a corollary question there, right? Has anyone ever seen a Pele's hair with a crystal in it? I'm not sure. I'll have to look more into that if anyone knows something about that, or more research industrious viewers. Yeah, let us know.
The one that was always interesting to me with the Pele's hair is we see the Pele's hair all the time around the eruptive vents. But when we started seeing the Pele's hair down or along the channel where it had like created or been able to, and not in just small amounts, but in heavy concentrations, miles away from the vent, along the channel, like it had somehow either blown all there and concentrated, or the channel itself was able to produce some form of Pele's hair locally in that one specific spot.
So you can produce Pele's hair from channels. Yeah, exactly. Yeah. So if you have, especially what you really need is you need something that kind of sticks into the river, like some rock or something, right? Like let's say you have like a rock that sticks over and it's not quite under the flow, but it's just high enough that some of those waves and splashes come and catch it, and the flow keeps going down the channel, but one piece is stuck, and then you can pull it apart and draw it out and form Pele's hair.
Mm-hmm.
Yeah. And then there are local winds around channels, and they can quite often collect in a similar area, or a whole bunch collect in a similar area. So yeah, there's some great videos, old school videos from Volcano Video guys that used to put out all the USGS updates on VHS, right? That has a video of exactly that, the lava channel and the Pele's hair is forming one after another in exactly the same place, and then collecting at the set of the channel. Skylights, right? When lava channel is completely encased and lava tube's underground, and you have a hole in the roof of that tube where it vents out, you quite often get Pele's hairs collecting there as well, because that's where all the gas is chimneying out, right? So you can have big mats around the skylights as well when those were a thing. Yeah, there are other ways in the fountains for sure, right? But usually much more localized and not going to cover a giant widespread area like this would actually do.
All right, I think do one more if that's cool with you. So this one is interesting, your opinion on it. Why is more Pele's hair this go around, or is there? Or are we just seeing it more?
I would say that we're just seeing it more, really, right? And it's going to where we can see it more, right? That's kind of the big answer. After the 2018 lava lake in Halema'uma'u, before the collapse in 2018, you could go out in the desert and find fields of Pele's hair, because that lava lake was also bubbling and venting, and all that was blowing into the desert, right? And much of the time the desert trail was closed because of the fog from that very same process, right? But you could, I remember seeing areas that were just like fields, like a whole high school gym area floor, like just one giant mat of Pele's hair. This would be like along the Cow Desert Trail areas, around the pit craters, areas that have erupted since then, right? But yeah, I think it's been collecting for a long time. It's kind of the location of where it's beginning and in which ways the wind blowing. So it was happening more so towards the desert, and the combination of this vent being all the way to the southwest side of the crater and in the wind direction blowing it northeast is putting it where people live more than before, right? So the combination of its location as well, but then also what I mentioned early on in our update, the fact that the vent is so close to the top of the crater wall, relatively speaking to before, also allows it to waft up and over up into upper areas. And that's something that might continue, right? And like I said earlier, Don Swanson has mapped out these layers of reticulite, which is like the pumice, right? You have to have a pretty tall fountain of lava, usually more than 400 feet-ish, something like that, to produce that really frothiest stuff. So taller fountains than we've seen here, coming from this exact spot, could produce reticulite that lands on that rim like we've seen in the deposits that exist there today. So that is a hazard for the area, right? Long term, and we've not had to deal with that in the area long term because the nature of eruption hasn't been what it is now. And yeah, that's where we are. And the really fascinating thing is, why are we episodic now, right? Like, how long could it possibly last like this? And we don't have any answers there, right? But we'll just keep tracking the dynamics and seeing whether this persistent fog in Pele's hair during a winter eruption, when winds are not always at trades, like how that can impact us in this following year and a year after, and we'll see what happens.
All right.
It's a good discussion to have, yeah.
Yeah. All right, well, we could always keep going, but we went really long last week, and we are at just about the hour and a half of us being on, minus the intro. So want to wrap it up here?
Yeah, let's do it. Yeah, appreciate everybody. As always, appreciate our ASL team, Carrie and Dano up top. We got Lou with our mid-roll and community corner on our back end producing as well, manning the chat. Mahalo, Lou, as always, every week. And all your crew, the Two Pineapples crew, always helping out as well. And for HVERI, Hawaiian Volcano Education and Resilience Institute, he's Dane DuPont. I'm Philip Ong. Until next week, everyone. Aloha.